Alright, today we're going to talk about solving molar enthalpy equations. It's important that you watch the units on these because they will be very important. The two numbers you'll need to use, you won't have to memorize them, they'll be provided for you, is the molar enthalpy of vaporization and the enthalpy of fusion, both for water. Standard temperature and pressure in this problem says, how much energy is absorbed when 53 grams of ice melts at standard temperature and pressure? Standard temperature and pressure is actually not needed to know for this problem. All you need to know is that it is at standard temperature of 0 degrees Celsius. Alright, so remember that vaporization and fusion are two different things. Vaporization is boiling and fusion is melting. So if we were talking about ice melting, we are going to need to use the enthalpy for fusion. But we solve these problems just like any dimensional analysis problem. We have our lonely number of 53 grams, so we write 53 grams of water because it's ice, so we're going to call it H2O. We set up some parentheses. The first thing we need to do is cancel the grams of water. Only one way to cancel grams of water, that's with grams of water. Now we want to eventually get to kilojoules because it asks how much energy, and energy is measured in kilojoules. And if this number is given in kilojoules per mole, then eventually we want to get to moles so that we can use this number to go from moles to kilojoules. So the next step will be moles of water. We know that in 1 mole of water we have 18 grams of water. We know that because if you look at the atomic masses on the periodic table, oxygen weighs 16 grams per mole, hydrogen weighs 1, but we have 2 hydrogens, so 16 plus 2 is the 18 that we get right here. Cancel out our grams, now we need to cancel out moles. Always 1 mole, and now because we're talking about melting, which is fusion, we want to use our heat of fusion number. 6.009 kilojoules. So because melting is fusion, we want to use our number for fusion, which is the 6.009 kilojoules. Then we'll multiply across. Remember, if it's on top you multiply, so it'll be 53 times 1 times 6.009. And then if it's on bottom you divide, so divided by 18 divided by 1. Remember that the ones don't really matter in multiplication and division. And we'll get 17.67 kilojoules. If you want to round to correct significant figures, though, you'll have to recognize that there are only 2 significant figures in our lonely number, so our answer can have only 2 significant figures, so round it up to 18 kilojoules. Alright, we'll solve 2 more problems. We're going to calculate in kilojoules how much heat is needed to melt 20 grams of H2O. So remember, because we're melting again, we're going to want 6.009 kilojoules. So I'm going to write that just to remind myself. That because it's melting, we're going to use the number 6.009 kilojoules per mole. Alright, so then we identify our lonely number as 20 grams. I just put that S there so we know the water is in the solid state. So 20 grams for a lonely number. We had to cancel grams of water by putting grams of water at the bottom. We're going to go to moles because we eventually want to get to kilojoules, and we know that this is kilojoules per mole, so we want to go to moles first. For every 1 mole there's 18 grams. In these problems we'll always be working with water, so you will always have a 1 mole for 18 grams at some point in time. Because it's melting, it's fusion, that's why we have the 6.009. So we canceled grams, now we'll need to cancel moles, and up top we'll put 6.009 kilojoules. 20 times 6 divided by 18, because if it's on top it's multiplication, if it's on the bottom it's division. And we get 6.667 kilojoules. But this has only one significant figure. On the test, you will know how many significant figures there are. There will generally be 3 to give you a more exact answer. Since we only have one significant figure, the answer must be 7 kilojoules. Final answer. Last one, we're kind of going in reverse. Here we've always started with grams and gone grams to moles, moles to kilojoules. This time we're starting with kilojoules, so we'll just go kilojoules as a lonely number. 4.97 times 10 to the 5th kilojoules. There's only one way to cancel kilojoules. That's with kilojoules. And then we'll go to moles. Now the question is, what number do we put here? Well, it looks like we're dealing with steam. The only way you get steam is by boiling. So we're going to use the number for boiling, which is 40.79 kilojoules per mole. So, kilojoules and moles. 1 mole, because it's boiling, 40.79 kilojoules. So in front of kilojoules, you'll always only have one of 2 numbers, either 40.79 or 6.009. Next up, only one way to cancel moles. It's with moles. And now we can go from moles to grams, which is mass. So we'll go grams on top. 1 mole, 18 grams, because we're talking about water. So if you note, when you start with kilojoules, it's the exact opposite. So whatever you ended with here, you start with here. Moles and moles stay the same. Whatever you started with here, you end with here. I would recommend always doing units first. Kilojoules to kilojoules, moles to moles, and then ending at grams. Worry about the numbers after you've taken care of the units. Then we get this number. But we can only have 3 significant figures, so I'm just going to keep the first 3 significant figures. So we have 219,000. If you write that in scientific notation, it's 2.19 times 10 to the 5th grams. Final answer. Come in early tomorrow if you have questions. Otherwise, good luck studying.